Day 6. Day 5. So day 6. An art dealer. Well, hopefully remember some of this from 6th grade, right? Like I said. This mean, medium, and mode, and what do you call it? Interquartile range. So let me just go a brief here. Let me just write some numbers here. 5, 6, 7, 8. Right. The mean. Now let me write another 8. Mean, you add them all up and you divide it by 5, right? So you do 5 plus 6 plus 7 plus 8 plus 8, and you get the mean. Think about your average. Mode. Mode's the easiest one. You don't have to do anything. It's the one that shows up the mode. So what's the mode here? 8. Now, if there was, that 8 was gone, what would be the mode? Well, there'd be no mode because none of them show more than the other. Median. Now, let me go back to mean. So the mean in its simplest form, right? So when you have something like this, you have to choose from the mean or median, or they ask you which one would be better suited. Well, average, right, mean, is when there are no outliers. Meaning, so imagine the ages of 6, 7 kids, and then you put me in there, right, and you took the average. Well, what's my age going to, how is my age going to affect the age of the other kids in this group? Well, when we do the mean and we put 51, right, so imagine adding 5 plus 5 plus 6 plus 7 plus 8 plus 9, and then boom, plus 51. Well, and we can divide this by 1, 2, 3, 4, 5, 6, 7. Well, that 51 is going to make everybody look much older than they are, right? So I am what they call an outlier. Right, it could be a number on this side, or it could have been a number on this side. It doesn't matter. So, in this case, when there's an outlier, you're better off using the median. Okay, so now, so the mean is better off when there is no outlier. So if you had that, you would add those 6 numbers divided by 6, and you get an average. Just out of curiosity, let's just do that. 5 plus 5 plus 6 plus 7 plus 8 plus 9, enter, you get 40, right? So you would add all those numbers up, you get 40, and divide it by 1, 2, 3, 4, 5, 6, and you divide by 6. So the average here is 6.6 repeating. Okay. Now the median, now let's say there's an outlier, me, right? You wouldn't use, and so this was 6.6, right? So now imagine if you add 51 to it, it'd be 40 plus 51, which is 91, and you divide by 1, 2, 3, 4, 5, 6, 7. Now the average is 13. See how that outlier, that huge number there, raised the average so much higher, right? So that is when you don't want to use the median. You want to actually use the median. Why? Because the median gets rid of the outlier. What's median? Median literally is, well, think middle, the number in the middle. You put them in order, and you can cross one by one from each side, and you work yourselves towards the median. So the median in this set of numbers would be 7. See how that 51, that outlier 51, doesn't really affect the data? It's because we got rid of it. So again, little review. Now, interquartile range, right? So something like, sorry, Fox and Whiskers they used to call it, or they still call it, divides your data into, and again, they don't have to all be the same size, divides your data into 25%. Right? Each of these sections here, it's worth 25%. Right? This is the median. Okay, this is the lower extreme, the lowest number. This dot here represents the upper extreme, or the highest value. This is Q1, and this is Q3. Okay, so just think median, divide your data into into 25% parts. Okay, so I don't know, let's make this up. 5, 6, 7, 12, 20, 25, 28, 31. So basically, I'm not going to do it, but You know, it'd say, hey, 25% of your numbers are from here to here, 25% of your numbers from here to here, etc. Well, you know what? Since I'm taking the time to do it, I might as well do it. Let's pick 5, 6, 8, 10, 15, 20, 30, 40. I don't know. I'm making this up. 1, 2, 3, 4, 5, 6, 7, 8. Let's pick one more. 50. Right. So you need 5 points to create a box and whiskers, right? A box plot. You need the lower extreme, the lowest value, which is 5. You need the upper extreme, which is 50. Then you need Q1, Q2, Q3. Q2 is the easiest one, is your median. So think about it. Median is a number in the middle, so it'd be not this, and we're working ourselves toward the middle, right? Here is your median. So median is 15. Now, from here, your median is, right, cut your data into on the upper half and the bottom half. In the bottom half, find the median again. From 5, 10, 6, and 8. And what's in the middle between 6 and 8? That would be 7. So that's your Q1. Your Q3 is the middle number on your the upper 50%. So 20, 40, 30, 20, 50, 30, 40. And what's between 30 and 40 would be 35. So we have your Q3. So now I have my 5 points. So if you had a number line, we can do that up. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, right? So imagine you had a number line like that. 5, first, your lower extreme would be here. Upper extreme is 50. Your median, sorry, your Q1, the middle of your bottom half would be about here, which is 7. Your median, the median number of this whole data here would be 15, which is right here. And the median of the upper half is 35, which is right here. Now from that, you create the box plot right here. And that's what. Now, what did that do? And then on top of this, I sometimes suggest you guys to do this, is write 25% in each section. Because it group your data into 25% parts. It's 25% sections. So from 5 to 7, it's 25%. From 7 to 15 is 25%. From 15 to 35 is 25%. And then from 35 to 50 is 50% of, 25% of your data. In a nutshell. A nutshell in a minute. So keep that in mind. Pretty sure you've seen it. An art dealer sold 7 paintings for the prices shown below, which measure best describes the typical price of these paintings. So again, if you wanted to find the average price of these paintings, you would not use the mean. Why? Because look, that's going to make the prices, if you actually did the mean, add them all up and divide it by 1, 2, 3, 4, 5, 6, 7, divided by 7, that 280 is going to make the average price go much higher and not really represent the real average price. So in this case, you would do the median. Put them in order and find a number in the middle. That would be the best way to describe the center. 2, so again, you might have a little trouble with this day 6. Number 2, survey his class of 30 students to determine their favorite dog breed. The results were graphed using a bar graph. So imagine you surveyed 30 people in your class, and their favorite dog breed, some of them said Labrador, some of them said Beagle, some of them said, I don't know, Chihuahua, some of them said, what's another dog breed, Husky, etc., etc. What statistics does this bar represent for the survey data? Well, it's not going to be the mean, right? You can't add the dogs and divide it. It can't be the range, highest minus the lowest. And it can't be the median, where you're going to line up the dogs and find the one in the middle. So this one was the most, right? The one that showed up the most. 3 is taking a survey. What kind of foods people like to eat with cheeseburgers. He found that most people like French fries than any other food. Which term should be used to describe this information? And again, would have been the mode, right? The other three make absolutely no sense. All right, so 4. Channel listed as heights of 17 people, which this statement describes the median of our data. Well, again, if you want to find the median, start from the end, right? Let's work towards the cell. So cut from 1 from each side. 4, and then this one, this one, this one, this one, this one, and this one, this one, this one. And the number in the middle, after you put everybody in order from least to greatest, is 60. So the median is 18. No. The median is 59.6. No. The median is 60. This one looks like the right answer. D, the median is 63. No. So just by choice, it's C. I didn't have to even read the rest. 5. The line plot below shows the number of hours Travis worked each week during the summer. Based on the line plot, which of the following is true? The median of the data is 25. The mean of the data is 25. Well, think about it. Does it look like if you add this, the average would be 25? It can't be, because look, most of the numbers are under 22. Right? Sorry, under 23. So there's no way you would add this and the mean or the average come out to 25. So A is, just by looking at it, not true. The mode of the data is 22. Is 22 the one that shows up the most? No. Got it. The range of the data is 14. Range is the highest minus the lowest. Highest value in this is 30. The lowest is 17. 30 minus 17 is 13. So that's also wrong. And the median is 21. Well, just by choice, 21. So again, you could line up all the numbers in order. So you would do 17, 18, 20 showed up 4 times, right? Line all the numbers up and then work yourselves towards the middle, right? You could even do it on the graph here. So cross this out, this one, this one, this one, and 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 this one. Look at that. The median is indeed 21. All right. Box plots. Okay, so 6. Let's see, hang on a second. If I have another sheet so I can actually keep this on the screen. So 6, here's a box plot, right? And which conclusion can be drawn? Conclusion A, the attendance on Friday and on Saturday have the same median. Not true, because the median on Friday is this line. The median on Saturday is this line, so A is garbage. B, the attendance on Friday has greater median, well, true, and a greater interquartile range. Now, the interquartile range, okay, is Q3 minus Q1. It'd be this value here minus this value. Okay, that would give you the interquartile range. Is the interquartile range of Friday greater than the one on Saturday? They actually look the same. Right, so if you subtracted this number, and then you subtracted this number, and this number, and you compare, it looks like they are the same. So B is also doesn't look like it's correct. C, the attendance on Friday has a greater interquartile range than on Saturday, but both have the same median. That's not even, well, the interquartile range looks the same, but the median, again, this and this, is not the same. The attendance on Friday has a greater median, true, but both data have the same interquartile range, right? This box here, the size of the box here and the size of this box are the same. Well, yes, so 6 would be D. I'm okay with that. 7. The line plot shows the number of inches each student's height increased 1 year for 2 different groups of children. Okay. Which of the following statements is true for the height increases shown in the line plots? All right, so let me read it from, I have another page here. Both the median and mode are greater from group 1. No, because in group 1, well, actually, group 1, yeah, a second, guys. Let me just read it correctly. Number 7. Both the median and the mode are greater for group 1 than group 2. Not true, because the mode in group 1 is 4, and the mode of group 2 is 5. So the mode here in group 2 is greater, so A is not right. B, both the median and the mode are greater for group 2 than group 1. The median is greater for group 2, but the median, okay, I think the median is greater in group 1. Okay, that wouldn't be true. And again, you can find the median by, again, crossing 1 from each side, right? And you find the median, and then you do the same thing from group 2. So that doesn't look like it's true. C, the median is greater for group 1, but the mode is greater for group 2. That looks right. So the mode, the one that shows up the most, is greater in group 2. And you know what? Let's just confirm that the median is greater in group 1. So let's cross 1 from each side and work towards the middle. Okay, the median is 4. And what's the median here? Cross 1 from each side and works towards the middle. The median is 3. So the median is indeed greater in group 1. So choice C is the correct one. Eight. Here's 2 box plots using his mathematics and reading test grades. Okay. Tanner wants to compare his median grades. Which of the following statement is true? A, Tanner's median grade is higher in math. That's not true. We can stop reading right there. So here's the median grade for math, and here's the median grade for reading. So A is already out. Tanner's median grade is higher in math than reading because the box and wizard plot for mathematics is higher than it's for reading. Median grade is higher in mathematics. No, it's not. Again, so B is also gone. C, Tanner's grade is higher, median grade is higher in reading, correct, because look, the median is here for reading and median is here for math. So the English one is higher because the box on the right is larger for his reading score than his mathematics scores. The box on the right. No, doesn't make any sense. But if you look at C, Tanner's median grade is higher in reading, correct, because the middle mark, which is what we're comparing here, it's inside the box for reading is higher than the middle mark inside the box for mathematics. Yes, this number is higher than this number. That's pretty much what they're saying. Okay. 8, 9. Which box represents a data with the largest interquartile range? So again, look at this and see which of these boxes, rectangles, right? The box here is greatest. Is it A? Is it B? Is it C? Or D? Look how big this one is, right? So the interquartile range is definitely greater in letter D, right? So visually you can check. Okay, so that one. Again, once you understand what the interquartile range is, that makes it much easier. 10, the box plots show cell phone prices at 2 different stores. How much higher is the median price at store X than the median price in store Y? So in store X, the median, this number right here, the number in the middle is 45. In store Y, the median, look at this, it's 30. So how much higher is it? Well, 45 minus 30, 15. All right, nothing to be afraid of, it's just data. All right, movie theater recorded a number of tickets sold for 2 movies. Here's the box plot of the data shown. Tell me which one is true or false. All right, the mean. Okay, so now, in order to create this, the box plot, right, we get all the numbers, 5, 6, 7, whatever numbers it is, right? And we find the median, and then we find the median again of the bottom half and the median of the upper half, and we get the 5 points, right? So, but problem is, if I just give you the box plot, I have no idea what the numbers were that were used to create this box plot. Because I don't have the set of numbers, this is already, I don't know. I can't find the mean. the mean number of tickets sold. I mean, you can't find the mean on the box plot. So this would be false, right? And again, because I don't know what numbers they used, right, to create this box plot. Now, if I had the numbers, right, if I had the list of numbers, again, 20, 30, 31, 45, whatever numbers is it that they used, right? If I had these numbers and I could look at these numbers, I could add them up, find the average. I can look at the other numbers that were used up here, add them up, find the average, and compare. But because I don't have it, A can't be done. B, the median number of tickets sold. One second. The median number sold for movie X is greater than the median number of tickets sold for movie Y. So movie X, the median was this. And for movie Y, the median was this. So this is definitely true. This one was false. The interquartile range for the number of tickets sold for movie X is greater than the interquartile range for the movie sold in ticket for movie Y. So definitely also true. Look. So when you talk about interquartile range, you're talking about the size of this box. Is that bigger than this one? Yes, it is. So also true. 13. The two new types of light bulbs. Extensive testing was conducted. How long the light bulbs would last and the number usage. Here are the results. What percent of type X, which is the first one on the top, light bulbs in the test had a lifetime of less than 14,000 hours? Well, here's 14,000 hours. So this is X and Y. Remember, let me put this. Don't forget, that represents 25% of the data. This represents 25% of the data. This represents 25. And this represents 25. They don't have to be the same size. They often, more likely than not, will not be. So, out of all the light bulbs, what's the percentage that was under 14? Under 14 is this group right here. So what's the percentage? 25%. What are the 5 number summary statistics for the lifetime in hours of the type Y light bulbs? Well, 5 numbers that were used to create this box plot was 6. This number over here, which is, let me write here, 6. The second number was 12. The third number was this dot over here, which is 17. The next number was this dot over here, which is 19. And finally, the last one, 22. So, these 5 numbers are the numbers used to create the box plot. Can you find the mean? No, you can't find the mean, and we just talked about that for each type of law, because in order to find the mean, I need to see all the numbers that were used to create the box plot, right? So I need to find the mean and I need to see those numbers to add them up and divide by however many were in the set to find the mean. But because I don't have those numbers, C I can't do. 13. The probability of 2 people in any given group of 13 having the same birthday is about 15%. True. Based on this information, what is the probability of 2 people in any group of 13 not having the same birthday? Well, that would be, well, remember, this is a complement, right? So the probability of having 2 people having the same birthday is 15%. So this is having the same birthday is 15%. If having the same birthday is 15%, not having the same birthday would be 85%. Right? Remember, complement. Right? Chance of snow today is 10%. What's the chance of not snowing? 90%. Right? There's a 2/3 probability that you will have homework in math class. Ooh. What's the probability you will not have homework? Well, again, 2/3 complement. So if you add those two, it will always give you 1. Okay. Which reminds me, I will post your probability test. Assuming I brought it. 15. Sam will choose one coin from this box and records value. How many different outcomes are possible? Well, there's a 5-cent coin. There's a 5-cent coin. There's a 10-cent coin. And there's a 25-cent coin. So how many possible outcomes? How many possible different outcomes? Well, you can either get a 5-cent coin, a 10-cent coin, a 25 coin. So there's 3 possible outcomes. 16. Look at the spinners. She will use the spinners to form a 2-digit number. She will use she will use the number the arrow spinner A lands on as the 10th digit, and the number the arrow lands on spinner B as the 1th digit. Okay. She will spin each number once. What 2-digit numbers are most likely to form? Now, most likely, folks. So she spins this spin over here. Most likely, she'll get a 1. She spins this spin over here. Most likely, she'll get a 6. So this has the bigger chance. $17. Jesse tossed the penny 5 times. What's the probability that the penny landed on heads all 5 times? Ooh, remember, it's half times half times half times half times half. So it's 1 over 32, right? So it is possible, but unlikely. Well, it's not certain, that's for sure. It's not impossible, that's also not true. It is possible. Is it possible and likely? Highly. No. Is it possible and unlikely, but unlikely? Yes. So 17 is. All right, that was day 6. Again, we will go over the box plots. Okay, so no worries if you remember it.